The guys on the back, can you read the font of the console? Not yet. Now? Yes? Okay. It's too big. It's okay. Okay, hello everybody. My name is Mariano Martinez Peck. I work as a software engineer for instantiations on the development of VA Smalltalk. And in this talk, I will show you can use Docker to improve your deployments and availability and scalability and so on. Sorry in advance, I know it's nap time, you all look tired, and I won't be showing graphics and 3D stuff. I will be showing text files and console. So, sorry in advance, and if you want to sleep, don't worry. I get it. So, before going to Docker, first, I would like to say I am far from a Docker expert. I am just showing my experience report of what I did. There are people even in the Smalltalk community with much more knowledge like me, like Julian Maestri, which is there. He helped me a lot with this. But basically, Docker, it's based on a previous concept that was already existing for a couple of years, which is the Linux containers. Linux containers are a way to virtualize physical hardware, but contrary to VMware or VirtualBox, where you run the whole operation system virtualized, with Linux containers what you do is you run a very small process, or multiple processes, but a really small kernel isolated from the rest of the containers, and they all share the resources of the host where they are running. So it's much more lightweight than running a whole operation system. It's something really small that runs, and it shares the resources of the host. So Docker came in and brought the concept of image to Linux containers. Something that really struggles me is that when VMware, VirtualBox use the word image, everybody understands. You can snapshot the VM and then you resume. And all people love that. Now happen the same with Docker. You can take a specification file, build an image, and then you just run it. Yeah, and we have the same for 40 years, and we still need to hear everybody saying that the image was the worst thing about Smalltalk. Anyway, that's just something that struggles me, and I won't really understand why. But anyway, Docker brings the concept of image, which allows you to specify what an image would look like, what it will have, and what it will do. And then allows you to run that image in a Linux container. Okay? It also provides a lot of features, a lot of new things, so it's not just the concept of image. It's plenty of features and tools, which we will see now. So why is it relevant for Smalltalk? I think that Smalltalk was quite easy for deploying. Well, with Docker, I think that is even easier. It somehow leveraged that thing of the development environment, the production, testing, or the thing. Oh, in my machine it worked. Yeah, but on server, on production it didn't. So Docker allows us to have a reproducible process where we can always be sure that we start with this and we get this image. So it's much easier to have a way to reproduce the different environments and simulate one environment in any machine. It allows you this famous infrastructure as code, which that's not true. It is infrastructure as config files, because that is not code. But it allows you to somehow code the specification of your deployment and then be sure that you can reproduce it. And that is quite valuable. It helps a lot to scale horizontally. We will see this on my demo. And finally, there are big players behind this. It's not just Docker. When the idea of running containers it's not to just run one container in one node, but instead build a cluster of nodes. Docker provides what is called Docker Swarm for that, but then Google provides Kubernetes, which is similar technology. There is OpenShift, and so there are really big players around these technologies. So how to Dockerize a Smalltalk application? That's the question. In this demo, I will just show one example, which you can find on our Instantations GitHub repository, which is a web application. It's a simple traffic light. You probably saw that if you were yesterday in my IoT workshop or on some of my blog posts. It's a very simple web app, and we will use that as the application that we are going to Dockerize and deploy. Okay, so no more slides. Can you hear me? Yes. So here I have a Windows machine where I have a VA Smalltalk running. I have a CSI adapter running, a CSI server on port 777, okay? I have this example already loaded, so you can see if I go to localhost on the port 7777/traffic light, I get to this web application where you just click on the lights and just highlight the line, and if you click on the green, that will bring a debugger. This is on purpose because tomorrow I will show some great debugging abilities. And again, I will use the same example tomorrow. So we have this web application. So the fun thing about Docker is to make a cluster. As I said, it makes much more sense when you use a cluster. But bringing many MacBooks wasn't very comfortable and not cheap. So what I did is that I brought here one ROC 64 board and one Raspberry Pi 3, okay? And I will run Docker in each of those machines, and they will act like a node of a Docker cluster, okay? So let me go to the command. So you can see, okay, you see the other way. So it's like that. So on the left side here, we have the ROC 64, which will act as the manager later on the swarm. And on the right side of the console, you see I am connected to the Raspberry Pi 3. Okay, so I am SSH into both of them. Okay, from my machine, from my laptop, I connected to them. Left side, that one, right side, that one. Okay? Okay, cool. So the most important, but one of the very nice things is that if you check, and I do u9/a, you will see that I am on ARM 64-bit. And the VA Smalltalk that we will run with Docker runs on ARM 64 bits. So VA Smalltalk not only provides ARM 32 bits, but also ARM 64. So this cluster will be running ARM 64 bits operation systems and VA Smalltalk. You can see this one, it was, I think it was Armbian, which is a variation of Debian for ARM. And on this side, I have Ubuntu server. On the Pi I have Ubuntu server. Okay, both are 64 bits ARM. And the other thing that I wanted to show you is that if I go to the Git repository where I have these Docker examples, Git, Docker, source, traffic lights. Okay, here we are. So this, it's, let's focus for the moment just on the Rock 64, Git remote, no, -b. So you can see I am using the exact Git repository as I showed in the previous slide. I am not running with any modification. It's the same repository that you can clone and use it. Okay. Now, to get started with Docker, how do you normally start with something? With a hello world, right? So Docker gives you a hello world, where you can say Docker run hello world. And here it says, unable to find image hello world locally. Latest pulling from library, hello world, blah, blah, blah. So what happened is I tried to run an image which was called hello world, which I didn't have locally on my machine. But the guy went to search for it somewhere. And that somewhere, it's a big, big, big repository from Docker, which is called Docker Hub. This is a repository where companies, people can submit their own Docker images. That way, you can start your Docker images from others that you can download. For example, you have images for Nginx, MongoDB, Ubuntu, Traffic, Docker, whatever. There are hundreds, thousands of images that you can use. And obviously, the hello world is one of these images. And if you look for it, you can see this is the image, which is official, provided by Docker. And if you see what it does, it says hello from, so it just prints to the console this message, which says, hello from Docker. This message shows that your installation appears to be working correctly. Okay, cool. So it's working Docker. But it shows how you can run an image. If it's not here, it will be searched for, downloaded, and run. So this is the most basic command. Then you can do docker image ls, and then you will see that the hello world image was downloaded of this size and some ID and whatever. You can also do docker info, and that would print you quite some information about this Docker engine, like the number of containers, the number of image, blah, blah, blah. A lot of information. So that's the very, very basics of Docker. So basically, you need an image and to run the image, okay? So how do we do that with our application, the web application? So the way you do this is you need to specify a file which is called Dockerfile. A Dockerfile is what Docker gives you to make the spec of your image, okay? So on the left side of the pane here, this is a local clone of the GitHub repository that I show you. So everything I'm showing here, it's just a local clone of that Git repository. So this is the Dockerfile that we will use. And one of the most important lines is the first one, where you said from where you want to start this image. Okay? So in this case, I am telling, because I like Debian, I am saying, okay, start from a Debian 9 and the variation slim. Slim is just a variation which puts the minimal amount of libraries so that it's small and it's more friendly to run in containers. Okay? In the same way I did this, I could have started from nginx or from Postgres or for whatever, Ubuntu, whatever I want. And it doesn't matter in which host I run this, it will always be a Debian. If I am on Windows, if I am on my Mac, or if I am in the Pi, if I tell that this would be a Debian image, it will be a Debian image. You don't care about what is your host. Your host, the only thing that needs to support is Docker Engine. If it supports the Docker Engine, then you can run most of the images. There are some architectural constraints, like not all images work on ARM, for example. So you need to know that in advance. So then you set some data like the version, I don't know, who is the maintainer, a description of the Docker. And then here, all I need to do is install the VA Smalltalk dependencies, which is basically libc, libSSL, which I need for CSI, and the, it's cutting me, and the locales. And the locales, yes. And curl, we forget it for the moment. So it's just libc, libSSL, and locales. So I install that with a normal apt-get, and then I just generate the locales. This is because VA Smalltalk allows you to specify which locale to use. So I just generate some locales. Then I tell to this image, whenever it will run, what is the working directory. Okay, so it will be opt app. Then it adds two directories into the image, which is opt bast92 and opt app, which are these two directories that are here. So these two directories will be copied into the image. And then I finally tell to run, I call a bash script which runs the image, which is something very easy. It just exports some variables, but at the end of the day, what it does, it calls the VA Smalltalk VM and passes as arguments the Smalltalk image and the ini file, which are the two files from VA Smalltalk, the image and the ini. So this bash script will just start my Smalltalk image. Okay? So now, going quickly to show this, here you can see how to build this image. So it's basically Docker. It's Docker build -f, and you specify the Docker file to use, and then just give it a name. And that will go step by step to build a Docker image. In this case, it took really a small number of seconds, and you see everywhere it says using cache, because I have already pre-built this image, because otherwise it takes many minutes, which I don't have. But that is the command to build the image. And once it builds, you can run it. You can see that if I do docker container ls, there is no container running so far. But if I do, if I run it, which I can copy paste it from here. The run, it's very simple. I just give some environment variables, and then I just tell which image to run. Okay, And then, if you can see now, at the startup, it starts to execute my bash script, which basically starts the VA Smalltalk VM, and then it starts CSI on port 777. So if I now go to a browser and I ping into the Rock64 machine, and I go to that port and the CSI, I can see that this is running inside a container. So I can show you quickly. If I SSH again into the Rock64, and now I do Docker container ls, you can see now there is one container running with this ID and this image and so on. So that's the container that is currently running. And you can see that if I kill it, because again, clicking the green light on purpose shut down everything. So if I check containers again, you will see none because the container stopped. Okay? The last thing I wanted to quickly show you, which I think is very nice, if you see the bast 9.2 directory, and you go to the bin, you can see the size of the virtual machine. So the headless virtual machine, it's about where it is? Here. No, this is the 2 megabytes and a half, the headless VM, and the other one is 3, I think. So it's really small. And the same for the image. If you now go to see the image that we are running, it's 3 megabytes and a half. So that CSI web application that we are running is 3 megabytes and a half, which again I think it's pretty nice. Okay, so that was basically how to run the Docker with one container and one image. But as I said before, the cool thing about this is how to make a cluster. We can use multiple nodes for this. And once you have the Dockerfile running, making a cluster, it's really easy. So here I have, like in the previous case, it was the Dockerfile. It was the most important file. Whenever you want to use a Docker swarm, which is called the Docker utility for making a cluster, it's called Docker Compose, okay? And this is the specification of the Docker Compose, which allows me to run a swarm. And I just defined 2 services. I defined a service called CSI and another service called Balancer. To the Balancer, because CSI, I will run 10 containers. If you see here, for CSI, I'm telling deploy replicas 10. So that means it will run 10 containers with the same image for CSI. So then it means that I need a web server on front to load balance the request across all the 10, in this case, CSI containers. So I put a balancer, it's called traffic, which is already on Docker Hub. So all I need to do is to tell, okay, use this image, which has traffic already loaded. And then some constraints like traffic should always run on the manager. So traffic, the web server, will always run on the manager of the cluster. And then I didn't put any replica because I want one web server running. For CSI, I tell 10 that I want to run. And the rest are small details. So the balancer, for example, is listening on port 80, and then it forwards the request to the port 777 of the CSI, and so on. So now all I have to do is, let's say I am on the manager, which is the Rock64, and all I will do is Docker swarm init. Okay? And they say, okay, this node is now a manager, and to add a worker to this swarm, run the following command. Okay, cool. So you go there, you copy paste it. I go now to Ubuntu, to the other machine, to the Pi. I run that, and now it will say that this node joined a swarm as a worker. Cool. So now if I go back to my manager and I do docker node ls, you can see that I have two nodes, the Rock64 and the Ubuntu. They are all available and ready to be working. The leader, in this case, is the Rock64. So this is just the setup of the nodes inside the cluster. And then I wrote two simple bash scripts to start and stop the swarm, which I won't get into the details right now, but it's two very simple scripts to start and stop the swarm. So you can see them here, stop swarm and start swarm. So I will just do start swarm. And you will see that it will start the service that I said was the C-size service and the balancer service. And if I now do docker service ls, you can see which are the deploy services, which is the balancer, which zero container has been started from one that should be run. And then from the C-size service, I still have 0 that have started out of 10 that I need. If I run this command again, because now a couple of seconds have passed, now I got the balancer already started, but yet none of the C-size containers. Okay? So now I wait a few more seconds. Okay, now I have 5 out of 10 that have already been started. And in just 1 second, I will have the 10. And if you now do docker service ps, and you check C-size, you can see the 10 containers are running, and each of them came to a different node. So the 10 containers were automatically split between all the nodes of the cluster. In this case, I only have 2 nodes. So you can see that we are 5 to Ubuntu and 5 to the Rock64. Something very cool is, like, if I now go to the same application, but now I need to get through port 80. Okay? Now, someone is listening to me. There is one container that responds to me. I don't know which one. But if I kill it, like clicking the green button, and if we wait a second, we will see here that there was one that was shut down, and automatically another one was started. So Docker detected that one of the containers went down and automatically started another one to satisfy the 10 replicas that I told him in the spec. And this is the last thing. Going a little bit more extreme, imagine that one node is, the whole node is down. So I will kill the Pi. Sudo power off. Okay, so I am tuning off the Pi. So now it's only one node left. So what would happen is, obviously what you imagine is that now the cluster will start as many containers as needed to satisfy the number of containers I said with the node it has available. In this case, it's only one node available, which is the manager. So if I run this again and I wait a second, you will see that it will be 5 of them dead and started again, but now on the manager. So let me go back to the slides and I show you that at the end. Yeah, show time, I already showed it. Yeah, so here's some information if you want to get licenses for VA Smalltalk, either open source for student or commercial. You have all the links there. And yeah, okay, you can see here 1, 2, 3, 4, 5 were dead, and all the containers were now started on the remaining node. Okay, I have more to show, but this is I have limited time. But if you want to see more, I will be here the whole week, so don't hesitate to contact me. That's it.